Let's continue with group 13 elements, some important compounds of boron. Some useful compounds of boron are borax, orthoboric acid, which is also called boric acid, and diborane. First we are taking borax. It is most important compound of boron. It's white crystalline solid having formula so Na2B4O7 into 10H2O. We can call it sodium tetraborate decahydrate. In fact, it contains tetranuclear units B4O5OH 4 times 2 minus is the charge, which is the correct formula. So the correct formula will become Na2B4O5OH 4 times dot 8H2O. Borax dissolves in water giving alkaline solution. Reason is boric acid is a weak acid, NaOH is a strong base, so solution will be alkaline in nature. Na2B4O7 plus 7H2O will give 2 NaOH plus orthoboric acid, which is weak acid, NaOH being strong, resultant solution is basic in nature. Preparation of borax, first we are taking from colemanite. Colemanite is calcium borate, Ca2B6O11. We heat it with sodium carbonate, we will get sodium tetraborate plus sodium metaborate plus calcium carbonate will be formed. Sodium metaborate, when reacts with carbon dioxide, it results in the formation of borax plus sodium carbonate is formed. From boric acid, if we react boric acid with sodium carbonate, we will get the salt sodium tetraborate plus 6 water plus carbon dioxide will be formed. Properties of borax. It's white crystalline solid, less soluble in cold water, but more soluble in hot water. The aqueous solution of borax is alkaline due to hydrolysis. Borax is therefore used as water softener and cleaning agent. It is used for cleaning of metals as well as gold. On heating, borax first loses water molecules and swells up. On further heating, it turns into transparent liquid which solidified into glass-like material known as borax bead. Na2B4O7 into 10H2O on heating loses all the 10 water molecules. Then it forms sodium metaborate and boric anhydride, which is also called boron trioxide. The metaborates of many transition metals have characteristic colors. Therefore, borax bead test can be used to identify them in the laboratory. For example, when borax is heated in the Bunsen burner, so after touching with HCl, we get a glass-like bead. Then we bring in contact with the cobalt salt, which gives cobalt oxide. So on the loop of platinum wire, a blue-colored bead is formed, which confirms the presence of cobalt, and it is due to cobalt metaborate. Copper sulfate also forms blue-colored bead. Copper sulfate reacts with boron trioxide, which is obtained by heating borax. So copper metaborate is formed, which is blue in color, from which it can be detected. Colors of metaborate: copper gives blue, iron gives green, cobalt gives also dark blue, chromium gives green, nickel gives brown. And this is the chemistry of borax bead test. Next we are taking orthoboric acid. Orthoboric acid or boric acid H3BO3 is a white crystalline solid with soapy touch. It is sparingly soluble in water but highly soluble in hot water. It can be prepared by acidifying an aqueous solution of borax. Na2B4O7 plus 2 HCl plus 5 water gives 2 NaCl plus 4 BOH thrice, which is also same as boric acid. We can write it BOH thrice or H3BO3, it's boric acid. It is also formed by hydrolysis of reaction with water or dilute acid with most of the boron compounds like halides, hydrides, nitrides. It has a layer structure in which planar BO3 units are joined by hydrogen bonds. BCl3 on hydrolysis with 3 water gives boric acid plus 3 HCl. Boron nitride, when hydrolyzed with 3 water, we get boric acid and ammonia. Colemanite, when reduced with sulfur dioxide and water, it gives calcium bisulfite and H4B6O11 is formed, which on hydrolysis gives boric acid. So if we sum up the reactions, the colemanite plus 11 water plus 4 SO2 gives calcium bisulfite or calcium hydrogen sulfide plus boric acid is formed. Diborane on hydrolysis also gives boric acid plus hydrogen gas is liberated. Boric acid is weak monobasic acid. Actually, it is Lewis acid or aprotic acid. It's not a protonic acid, means it is aprotic acid, but acts as Lewis acid by accepting electrons from hydroxyl ion. So it accepts OH ion to form BOH negative ions so that its octet is complete plus hydronium ion is formed. Since only one hydronium ion or one H ion is given out, that's why it is monobasic acid and it is weak in nature. On heating orthoboric acid above 370 Kelvin, we get metaboric acid. Metaboric acid on further heating gives tetraboric acid or pyroboric acid, which on strongly heating gives B2O3 or boric oxide. So first, what one water is lost, and we have got metaboric acid. 4 moles of metaboric acid on heating give H2B4O7, which is tetraboric acid or pyroboric acid. And tetraboric acid on further heating at 673 gives boron trioxide plus water. This is test for borate ion. A mixture of ethyl alcohol with boric acid burns with green edged flame and it is due to formation of volatile triethyl borate. Boric acid reacts with 3 moles of ethyl alcohol and gives triethyl borate C2H5 thrice BO3 or POC2H5 thrice plus 3 water is formed and it is volatile and burns with green edged flame. This can be used as a test for borate ion. This is the structure of boric acid, in which this has a planar structure and there are this dotted line represents hydrogen bond and thick line represents covalent bond. It's a hexagonal type structure and dotted line are representing hydrogen bonds. And due to this extensive hydrogen bonding, it exists as solid. Uses of boric acid in manufacture of heat-resistant borosilicate glass, which is also called Pyrex glass. It is used for oven glasses, which can be used in oven and also in the lab, making of beakers, test tube, which can be used for heating. It is used as a preservative for milk and foodstuffs in the manufacture of enamels and glazes in the pottery. The aqueous solution of boric acid is used as mild antiseptic, especially as eye wash under the name boric lotion. Boric acid is also used in carom board. Next we have a question, why is boric acid considered as weak acid? Because it is not able to release H positive ions on its own. It receives or accepts OH ion from water molecule to complete its octet and releases H positive ion from water. So it's considered as weak acid. It is also used in prickly heat powders for the children and adults as an antiseptic.